All right, thanks everybody for joining us today. This is another installment of, we try to make this monthly, but pretty much our monthly channel webinar where we go into a new product launch, maybe an application, new features, just a quick 10 to 20 minute webinar that we can update you on what's going on with our product group. So today we're going to talk about the SmartNode EFM integrated access devices. So this will be an extension of our 4670, our 4990, and then also our 5490 ESBRs. We'll be adding EFM. And today you'll hear from Ramon Felder, one of our executive PLM. I'll pass off to him in a second, but just as housekeeping, as usual, if you do have any questions, please enter them into the question tab, and then here at the end in about 10-15 minutes, we'll go ahead and do a Q&A and answer any questions you have. And if you do have any additional questions thereafter, you can always shoot me an email or ask support or sales@patent.com. So I'll go ahead and pass it off to Ramon.
Okay, thank you, Tyler. Welcome everybody from my side. As Tyler mentioned, we're gonna talk a little bit about the EFM integrated access devices and the addition of EFM functionality to our SmartNode product line. For some of you, this may be a new technology, so we decided to add a part about some background information on what EFM is, then talk a little bit about solutions and overview of the products, because there's more than just the SmartNode IADs that run EFM in the patent portfolio. A very brief introduction of competitive products in the market, and then a quick overview of the models that support this EFM technology. Good, so let's get started with what is EFM. So first, the acronym means Ethernet in the first mile. The first mile is opposed to the last mile traditionally in telecommunications network. The last mile is the connection from the operator to the customer premises. Now EFM turns this around, says this is really the first mile. The first mile, the customer, should be in the focus, and that's why this is the first connection, the first mile into the carrier network infrastructure. And why is it Ethernet in this first mile? Well, Ethernet is becoming so ubiquitous both on the customer premises. There's Ethernet LAN networks everywhere, but also more and more in the carrier backbone infrastructure. The data centers are wired up with Ethernet, and there's more and more Ethernet-based wide area transmission technologies, Metronet, Ethernet, and so forth. So it's just a logical extension to say, okay, let's do Ethernet end-to-end, and in particular also let's do Ethernet on this last mile / first mile connection between the customer premises and the network. So EFM defines a number of standards which support the Ethernet protocol over different media in the access network, primarily of course also the copper infrastructure, which is everywhere, which has been built up over a century for telephone services, but also over fiber-based and other access network infrastructures. Good, so what does it provide? If we look at the existing copper infrastructure, it is a reliable connection, it's high speed, it's low cost and fast installation if we can use the infrastructure which is already in place. We don't have to do fiber deployment and dig trenches and so on. So that's what EFM is adding. Now, still to date, and we could say historically, ATM has been the most used, most deployed transmission protocol in that access infrastructure. And so why would we change that? What does EFM add in such an infrastructure? To explain that a little bit, we've drawn up here these two protocol stacks. On the left side, you see a G.S connection with the ATM layers in between. So ATM adaptation, Ethernet over ATM, and then the Ethernet layer and the IP layer on top. So this is how a typical ADSL access works. This is how a G.S ATM-based access works. And then on the right side, we see the stack as it looks in a EFM network, and basically just the whole ATM overhead has been eliminated. So what that makes is you have one less layer that you don't have to configure, so you don't have to set up ATM PVCs, etc. You have less overhead, which means you have more usable bandwidth, 10 to 15% more bandwidth depending on line speed, etc. You have less overhead and simpler configuration. So these are the main advantages that EFM brings over ATM-based DSL access networks. Good, so this is the layer which gets eliminated. Now, there's other points to consider. I mean, ATM was designed for a particular reason as a multi-service protocol able to carry voice and data over a link. And when the protocol was defined, the bandwidths which were available at the time were much lower. So there was a concern about sending big data packets. So for example, Ethernet packets with 1500 bytes over a low-speed link, because that transmission could delay voice connection, could introduce jitter, which could degrade voice quality or video quality, etc. Now, in the meantime, over the last 10 years, 15 years, the speeds in all parts of the network, LAN, backbone, and access have increased quite dramatically, and these short ATM cells are really no requirement anymore to carry real-time data. So you can see that in the table there below, explaining what the transmission delay is of an EFM packet or of an ATM packet, and how much time those take to be transmitted over the network. And we can see that on a 10 megabit link, for example, an Ethernet frame can be transmitted in 1.2 milliseconds. So there's hardly any delay or jitter introduced by that anymore. So as the backbones are also migrating to MPLS IP, we have now the possibility to do end-to-end Ethernet. Good. So again, what is EFM? Some more details. The line rates are basically the same as on G.S HDSL. It's the same layer 1 technology with 5.7 megabits per second over a single pair. And then EFM also defines bonding technologies which let you combine several wire pairs together to reach, for example, 20 megabits per second in a symmetrical mode. It is technology that allows you to go pretty far and cover pretty much every installation on every copper wire which is out there. You can see there it can go close to 10 kilometers. It's symmetrical, which makes it well suited for business applications which have up and downstream rate requirements in the same way. There's still also a lot of T1, E1 circuits out there, so those can be replaced with EFM technology, and it's also technology coming from the G.S space, which has good noise immunity, so it can be easily combined into the wiring tunnels and cabinets of the existing infrastructure. Okay. This table shows a little bit of context of G.biz. EFM is based on G.biz with other DSL technologies. You see symmetrical, the line rate and the reach, and how it compares with those other technologies. Good. So you probably know that Pattern has a long history in DSL technologies. We have a wide portfolio also of, for example, Ethernet extenders, which go back to really almost the earliest DSL technologies becoming available. That has evolved at the same time as the voice over IP products and the SmartNode product line. And today, with the EFM technology, we are able to offer a pretty complete portfolio, which does not only include integrated access devices like the SmartNode, but it also includes EFM routers. For example, the on-site 3304 model, or it includes bridges like this 3088 AI, and we also have a concentrator which provides up to 24 ports of EFM in a single 1U 19-inch chassis. So you can build up a complete campus network, small carrier access network, or industrial network with EFM components on both ends of the line from Pattern. Since it's a standard, we're of course also interoperable with third-party devices on the concentrator side or on the CPE side, so you can combine the CPE or the concentrator with products from third parties. Good. So if we look at this overview and compare it a little bit with what is out there, some of the well-known names in EFM are Hatteras, which is now Overture. They have concentrators, bridges and routers, but there's no IADs in that portfolio. Actelis is a well-known name there. Again, no IADs are available in that portfolio, only bridging CPEs, not even a routing CPE. And on the other side, One Access is concentrating on the CPE and on the IAD side, and doesn't offer concentrator devices in that space. So we believe that we are in a pretty good position there to offer EFM solutions in various applications and for various requirements, and have the right product for every application. From a SmartNode perspective, the EFM WAN interface is just an additional option of a WAN uplink, which is available on the integrated access devices, so namely the 4670, the 4990, and the 5490 series. They're available in two hardware versions, one being a 4-wire or 2-pair solution, which reaches up to 11.4 megabits per second over 2 pairs, and there, and I think this is also a pretty exclusive feature, we have a 4-pair or 8-wire option, which delivers up to 22.8 megabits per second symmetrical. So you can get an integrated access device, 20 meg symmetrical uplink over copper with a standard compliant EFM interface in a single device. The SKUs, which you can find on our website and in the price list, are designed or denominated with the 2G or 4G option in the SKU name here. So this signifies EFM WAN uplink. Of course, it's also described then in the description of the product. So look for the 2G or 4G extension in the SKU, and that will provide you with the EFM uplink on these different SmartNode devices. Okay, so this was our quick introduction to the EFM product line. There's of course more product information available as usual on the datasheet pages which we have on our website, so have a look there at the 3088, at the 3300 series, and at the SmartNode IADs. As usual also, your sales director, your local patent sales rep will have more information, can give you pricing information if you don't have access to our price list. And yeah, with that, let's please stay tuned also for upcoming invitations and the recording of the webinar. And I think Tyler will have some more to say about that. Right.
Yeah, thanks, Ramon. Let's go ahead and jump to the Q&A. I know we don't have any questions right now, but see if anything comes in.
Okay.
Looks like you answered everybody's question.
Yeah.
So as Ramon mentioned, you can expect tomorrow or the next day that usual follow-up with the recording of this webinar that you can send out or watch again, and then also a webinar invitation to the next webinar. We don't have a set date, but what we will do is just schedule it for a certain date, and if you do sign up and we change that date, it'll give you a notice and change it in your Outlook or whatever scheduling device you use. So the next webinar, we're going to go ahead and update you on what we're doing with Link. You did get an email a few months back that we are recently certified with 2013, Link 2013. So we just wanted to update you on that and what we're planning for the future with Microsoft Link and our capabilities in that community. So again, there's no questions, so we'll go ahead and close this. Thank you, Ramon. Thanks everybody for joining, and look out for that follow-up in the next couple days.
Thanks everybody. Bye-bye.